Hello CS112, today I will be going over Lab 7, which was making a deep copy of a three-dimensional list. Now this video might be a little bit longer than my others because I really want to go over what a deep copy is versus a shallow copy, because that is a very important course concept that you guys should take with you. But if you guys wanted to just skip through to see exactly how to do the deep copy as a 3D list, I will have a little table of contents in this video's description down below. So again, in Python Visualizer's live programming mode, I'm just going to paste this. This was the three-dimensional list you guys used in your lab assignment, so I'm just going to save that because I don't want to type that out on video. That will take me ages. So let's get that way out of the picture here. So let's start with a list named X, 1, 2, and 3. As you can see on the right here, X is pointing to an object of type list with the values 1, 2, and 3. If I just simply said y equals x, so you can see on the right here, y is now pointing to the same object that x is. This is a shallow copy, okay? This means that if I did anything to x, if I added any values, changed any of these values, or removed it, the same would happen to y, okay? That is not what we want to happen. That is a shallow copy. That could cause a lot of discrepancies in your code if you have like long lines of code and you don't want y to be changing. If it was a deep copy, I'm just showing, I want to show you what it looks like over here. It would look like this. These two objects have the same exact value, but they're separate because y is now pointing to this object down here and x is pointing to this object down here. While they have the same value, they're two separate objects. So if I made a change to x, it wouldn't affect this object down here because I'm only making changes up here. So now how do we do that in terms of code? You guys know two very useful list methods. One is called append and the other is called extend. I'm going to go over extend first because that's the easiest. So I'm going to initialize y to an empty list. I'm going to say y.extend x. Okay, as you can see here, just like I showed you before, this is a deep copy. All right, let's change x to see if y changes too. Okay, because that's how we are going to test if y is truly a deep copy. So today's theme will be let's say fruits. So mangoes. As you can see, only x was changed. What the method extend does is it takes as an argument any iterable object, such as a list or a dictionary, and it will append, or I'm not going to use the word append, it will add every single element in the order that it's read to the list y. Gotta plug in my laptop, give me a second here. Okay, so as I said before, it will iterate through an iterable object and add every single element to the list before the dot. So that does create a deep copy. Now let's try the same thing, but let's use append. Append is completely different than extend. A lot of people get the two mixed up, but especially when you're working with deep copies, they do two different things. So as you can see here, I'm just going to go ahead and comment this out for now. Looking to the right here, y is initially pointing to different objects than x is, but the contents within x are pointing to y. Now I wonder why that is. Let's print out y and see what happens. So we print out y, and that's interesting. It's a two-dimensional list. Why is that? Because append takes the whatever its argument is as a whole and adds it to the list. So what it did was it literally took all of x and it appended it right here. So you have a two-dimensional list, which is what that was. So that is why, as you can see right here, there's two arrows. This first arrow is a single-dimensional. This makes it multi-dimensional because the first object is a list, the second object is a list within a list. And this is still a shallow copy because they're pointing to the same list. So if I was to change, as I'm sure you guys already saw, x0 to mangoes, they both get affected. Y and x are now both have mangoes at the beginning of their thing. So how can we use append to create a deep copy? Now this is what you guys should already know, is you guys need to do exactly what the extend method did that I showed you at the beginning, which, if you guys remember, extend iterates through the object. So we are going to use a for loop, if I can spell, to iterate through x. and we are going to say y.append. And what are we going to append? Are we going to append x? Are we going to append y? If you said either of those, you're wrong. It's xi. All right. So you can see here we now have two completely different lists. So if we were to change x0 to set that equal to, let's say, pineapple, only x was affected. All right. So back when I was taking this course, when I was told to make a 3D copy of a deep copy of a three-dimensional list, the only hint I was given was to first create a deep copy of a single-dimensional list, and then a two-dimensional list, and then a three-dimensional list, because there is a pattern. So I'm going to go ahead and create a deep copy of a two-dimensional list. I know that some of your professors have already done this in class, but I'm just going to do it for the sake of what I was told when I was in this class, is to go in order. So here we have a two-dimensional list. I'm going to add another list here, just so you can really see the two dimensions. What fruit should go next? Let's go apples. Okay. So as you can see here, it's already not a deep copy, because while y is initially pointing to a new object here, inside it's pointing to the same object as x is. So we need to find out how to get to these specific data within the lists. So as many of you guys already knew, we need a second for loop. So range length, and in here, remember, it's going to be xi now. All right, and we need to do y.append, because once we're within this, we're right here now. This is where this is the range length of xi. We need to append xi. So I'm going to copy and paste it because I'm lazy. Xi. We want to append xij, right, guys? Because we need to go and get each of these individual things. So as you can see, it has no attributes append, because that's not a thing. It's append. So I'm appending xij. Xij is each one of these individual things. But as you can see, my list looks a bit funky, sort of like it did originally. Or sort of like it did before. So let's print out y and see what's going on. So we print out y, and it's not in this format. What's going on? Well, that's because we should try separating these values out. Now, many of you guys knew how to do this too, but I'm just going to go over it real quick. I'm going to initialize a list within here, set it equal to an empty list. I'm going to call it inner because it's the inner list in this example. And instead of y appending, I'm going to have inner append the individual values. Now, we want a way to store all of inner's work because it's working very hard to get each of these values. How are we going to do that? Right after this for loop, right after this for loop here, before it goes back to the main for loop here and sets inner back equal to 0 and we lose all its work, we are going to append it to y. So y.append inner. So now as you see here, this sort of is looking exactly like it should. So when we print y, we get the deep copy of that. So let's confirm our suspicions and change the value of x. Let's print out, what am I doing? Let's do x0, what's another fruit? Well, it's not a fruit, but you guys get the stuff. So I'm actually going to change x1 because I want to still have my numbers. So now you can see here that only x has carrots and only y has apples. And also, looking at these arrows, no arrows associated with y, which includes inner. Inner is also an arrow we need to look out for here. None of these arrows are associated with anything x is pointing to, right? You can draw a line right through here and separate the two. These are not related at all. While they are deep copies of each other, or y is a deep copy of x, they are not related to each other, so we can make changes freely and not worry about the rest of our code. So now let's move on to a three-dimensional list. This is extremely similar to the pattern we got going on here, although I'm going to do a little clean slate here. So again, this whole thing right here, this is the list that you guys used in the for the example of the actual thing you had to do during your lab. which is just, it's a giant list, a smaller list with a whole bunch of stuff inside. So really quickly, just so you guys can see what you're working with, I'm going to print out the levels. So it's a three-dimensional list. So I'm going to print out x, 0. So you can see here, now it's a two-dimensional list like the one we were working with before. Then I'm going to print out, whoopsie daisy, x, 0, 0. Now it's actually gotten, as you can see, this is x0. x0, 0 is just the first list here, and as you can guess, x0, 0, 0 is going to be the first element. So just right off the bat there, x0, 0, 0 is the first element. If you're thinking 3 for loops, you are correct. So I'm going to initialize y here real quick, and I'm going to go ahead and make a very rough structure. So for I in range length, let's say x again, because that is the name of our list that we're iterating through. Now, as you remember, x is now a two-dimensional list. So for j in range length xi, it's very important that we're iterating through xi now, because now that is a two-dimensional list. So the third for loop, I'm going to say k, this can be anything you wanted. It can even be like watermelon, but I'm going to keep it as k because I don't want to type watermelon. Range length. Now in here, it's going to be x, I, j, because remember x00 was a list, and now we're iterating through this list. And let's go ahead and print out what x, I, j, xi and j, remember it's a list, so we're getting there. If we have that k, we have every individual element's value, which is exactly what we want. So we know what values we're working with now, okay? So as before, I'm going to sort of append it to y and see what happens. Append. Alright, so again, it looks funky. This is not how it should look. So let's print out y and see what's happening, and if you're guessing it's going to be a single-dimensional list instead of a multi-dimensional one, you are correct. So you can see here, it's just all in one list, and we want the same data structure as this. So, if you guys remember what we did last time, we created an inner loop, or an inner list, to account for the list within a list. Now, if you guys took the hint from adding another for loop, we're going to need to initialize two lists within here. So I'm going to call the first one outer because that's more outer than the other lists we're going to be creating, and this one inner. So now, like the last one, I'm going to have inner appends all this jazz right here. And right before inner gets initialized back to itself when we're coming back here on the same indentation as it, I'm going to have outer appends that. Okay, I hope this is making sense to you guys. So we have outer appending inner right before it gets to that. Alright, so now we've done that. Let's go ahead and print y and see what happens, guys. Uh-oh, it's still an empty list. That is because we need to take a third step, guys. This is a three-dimensional list. So right before outer right here gets initialized back to an empty list, once it's done its first iteration, you guessed it, guys, we're going to append it to y. So y.append outer. So now I'm going to print y real quick just to please you guys. It is a three-dimensional list, and it's exactly like x up here. However, what if it's not a shallow copy? Let's go ahead and print, let's set x, let's change the first entire list of x. So that's x0, 0, x0, 0 equals a list that contains watermelon. Alright, let's pretend that says watermelon. And then I'm going to print x, and then I'm going to print y. So first I'm going to get rid of this statement right here. That's going to, alright. As you can see, only x was changed when I changed the first value. So that means that this is in fact a deep copy. Now let's look down here. Let's think about this visually. So like before, this is a very long and messy thing. Alright guys, it's a very long and messy thing. So, I'm going to get rid of this line real quick so it's a little cleaner. None of x's things right here, none of them are connected whatsoever with any of y's things. So of course they're going to be arrows for inner and outer. Those are the two lists we initiated. But you can draw a line right through, starting right here and going right through here. None of the objects that x or any of its contents are pointing to are in any relationship with these guys. This is pretty ugly, but I'm sure you guys can see that, like, you can literally draw a line straight through here. Alright, straight through here. And none of these objects have anything to do with these objects besides the fact that they are the exact same value. So, yeah, to sum it up, you can have any dimensions. You can have like 100th dimension list, and with that extends, it'd be very ugly, but it's going to be a lot of for loops, and you just keep having to make these inner outer lists, appending, all that good stuff that you guys love so much. But yeah, it's just following this pattern right here to make that deep copy. So yeah, just in your loop, you just need to find a way to get to the numbers themselves, append that to a list, append that to another list, and so on and so forth. And then you will have a deep copy. I really hope this video helped.